Black holes are one of the strangest and fascinating things in the universe. In this video we will know about how black holes are formed, what are different types of black holes, and what are its components. Black holes are points in space that are so dense they create deep gravity sinks. Beyond a certain region, not even light, the fastest known entity can't escape the powerful tug of a black hole's gravity. And anything that ventures too close, be it star, planet, or spacecraft, will be stretched and compressed like putty in a theoretical process aptly known as spaghettification. These infinitely dense points in space will a black hole. Black hole's boundary is called its event horizon. When something crosses event horizon, it collapses in the singularity, an infinitely small, infinitely dense point where space and time and the laws of physics no longer apply. All the electromagnetic waves coming towards the black hole ends into the singularity, in the center of the black hole. Once you are inside, there is no coming back, even for light, the fastest known entity. To get out of here you should have speed more than that of light, which is the limit of the cosmos. The radius of a black hole is known as Schwarzschild radius. Because black holes swallow all electromagnetic radiations that falls on it, astronomers can't spot them directly like they do the many glittery cosmic objects in the sky. But there are a few keys that reveal a black hole's presence. For one, a black hole's intense gravity tugs on any surrounding objects. Astronomers use these erratic movements to infer the presence of the invisible monster that lurks nearby. All objects can orbit a black hole, and astronomers can look for stars that seem to orbit nothing to detect a likely candidate. That's how astronomers eventually identified Sagittarius A star as a black hole in the early 2000s. Has matter around its accretion disk. In a accretion disk there is dust and gas swirling around it, very caudically. It's incredibly hot, we are talking about millions of degrees, and going really fast, a significant fraction of speed of light, and this is the black hole feeds off and get bigger and bigger over time. We all noticed that the accretion disk doesn't extend all the way into the event horizon. Why is that? So that's because of the innermost stable circular orbit, and for matter around a non-spinning black hole orbit is at 3 Schwarzschild radii. It also contains quasars, jets of particles that blasts out of supermassive black holes. So this is the innermost orbit of the matter going around black hole. If we go inside this orbit, then we will very quickly go into the center of the black hole. But there is something that can orbit closer to the black hole, and that is light. Because light has no mass, so it can orbit at 1.5 Schwarzschild radius. It's a sphere of photons orbiting. What would happen to you if you fell into a black hole? The experience of time is different around black hole because black hole wraps space and time. Some outside you seems to slow down as you approach the event horizon. Time passes slow for you. At some time you would appear to freeze in time, slowly turned red and then disappear. How soon you would die depends on the size of the black hole. A smaller black hole will kill you before you enter in its event horizon. When you probably could travel inside a supermassive black hole for quite a while. As further away from the singularity you are, the longer you live. Using Einstein's general theory of relativity, a German scientist named Karl Schwarzschild calculated that any mass could become a black hole if it were compressed tightly enough. But it wasn't until 1971, when theory became reality, astronomers studying the constellation Cygnus discovered the first black hole. Black hole wraps around space-time fabric. The easiest way to think about black hole is just that anything that has mass. So, the Earth has mass, and one of the reasons that Moon orbits around this Earth is because the gravitational attraction of two massive bodies. So, the Earth is distorting the space around the Moon, and so that would keep the Moon in orbit. Now, take that to an extreme. Take something that has massive as a sun or a mass of millions of sun and put it at a single point, and that its distortion will you get coming from that amount of mass in a single point. As powerful as black holes are, they will eventually evaporate, process called Hawking radiation. To understand how this works, we have to look at empty space. Empty space is not really empty but filled with virtual particles copying into existence and then annihilating each other. When this happens right on the edge of the black hole, the virtual particle will be drawn into the black hole and other will escape and become a real particle. So the black hole is losing energy. This happens incredibly slowly at first, and get faster as a black hole becomes smaller. When it arrives as mass of a large asteroid, it's waiting at room temperature. When it has a mass of a mountain, it radiate at about heat of a sun. In the last second of its life, the black holes radiate away with energy of billions of nuclear bombs in a huge explosion. But this process is incredibly slow. The biggest black hole you know might take a Google years to elaborate. Now we're going to talk about black hole lying in the heart of our Milky Way galaxy, which is Sagittarius A star. Sagittarius A star was first recorded in February 13, 1974. The supermassive black hole has a diameter of 44 million km and lying at a distance of 26,000 light-years from Earth. Mass of about 4.5 million solar masses. Now the question is, which is the first black hole which was pictured? M87 or Messier 87 black hole located in M87 galaxy was first pictured on Wednesday, April 10, 2017. With a diameter of about 1,20,000 light-years, M87 is at a distance of 55 million light-years from Earth. M87 has mass of about 6.5 million solar masses, is one of the most massive known, and like a cosmic searchlight, a jet of subatomic particles traveling nearly at the speed of light is streaming out of it, as far out as about 6,000 light-years. Thanks for watching. Write your thoughts in the comment section and get subscribed for more interesting